Newton's idea that space and time together form a simple, rigid framework dominated all thinking until the final years of the 19th century. Then a problem occurred. Scientists experimenting with light found that no matter what they did to it, they could never alter the speed at which it traveled. This and other anomalies eventually led Einstein to his theory of relativity, in which he concluded that the speed of light is the only absolute constant, and that everything else, like space and time, are variable.
Einstein's special theory of relativity was really the death knell for the old concepts of space and time. Einstein showed that absolute space and absolute time couldn't exist any longer.
According to relativity, space and time were no longer a rigid framework, but were instead a fabric which could be stretched and distorted.
Einstein, in fact, had two theories of relativity. In one, he showed how time can slow down if you travel very fast, close to the speed of light. That was known as his special theory of relativity. In general relativity, he showed that time can slow down if you sit in a strong gravitational field.
Just as a magnet creates a magnetic field, so all massive objects create around themselves a gravity field. And just as a magnetic field affects objects within it, so a gravitational field affects not just objects, but light and even time, bending, stretching, or compressing it. The more massive the object, the greater the field it creates, and the more it bends space-time.
Imagine you approach a massive star. The closer you get to the star's gravitational field, the slower your clock will run. Even your biological clock, your whole concept of time will be running more slowly than it did further away from the star.
The byproduct of time slowing down is time travel to the future.
Both Einstein's theories of relativity say that travel into the future is allowed. In fact, we've proven it experimentally. One way is to travel very fast, so you'd head off in a rocket, travel at close to the speed of light and come back again. Because you've traveled very fast, your clocks will have run more slowly. And so if you've been away for 1 year according to your onboard clock, maybe 10 years have gone by on Earth. So in essence, you've traveled 9 years into the future. Another way of traveling to the future is to go and orbit a massive star. If you do it for a year, again, you may come back and find that 10 years have elapsed on Earth. So either way, time travel into the future is possible.
And this is a fact we have to deal with. Satellites orbiting the Earth do travel minutely in time. Because of the speed they travel, their onboard clocks gain milliseconds relative to clocks on Earth.
Time travel to the past, however, is more tricky. But despite that, Einstein's relativity says that it's allowed. It was shown half a century ago, in fact, that there are solutions to Einstein's equations. The mathematics shows that time travel to the past is possible.
One candidate for how time travel to the past might be physically possible was via one of the universe's more exotic features: black holes.
Normally we think of a black hole or a collapsed star as being a point of zero size and infinite density, surrounded by what's known as the event horizon, the point of no return. But most stars actually spin, and when they collapse, they will start to spin more rapidly. And a spinning star that becomes a spinning black hole doesn't have a point singularity at its center. Its singularity looks like a ring, like a donut. One possibility was that maybe we could travel into a black hole, avoid the singularity, and travel through the middle and come out the other side. Because space and time were linked, you would not only have to come out at another region in space, you could come out at another point in time. This sounds like it's the ultimate freedom for us, that we can travel both into the future and in the past. Einstein's theory of relativity gives us this wonderful freedom of moving back, changing history, going into the future, see what things are like, and coming back again, finding out what mistakes we might make and avoid them. This would imply that the past, present and future all exist. There is no present moment to distinguish past from future. All times coexist, time just is. And so the future is already out there. The only way to understand this was to link the 3 dimensions of space with the 1 dimension of time to make what became known as 4-dimensional space-time.
Space-time is certainly different stuff from space because it's 4-dimensional as opposed to 3-dimensional, which is a big difference. So it's just that time really has to be brought into the picture. It's one thing, which is space-time.
Let's imagine what this might be like. 3-dimensional space implies a volume, and you can move anywhere in that volume. Once you add time as the 4th dimension, another axis, then this block of space-time would contain within it past, present and future, all at once. Time is frozen, all times exist together. So just as you could say over here, over there in 3-dimensional space, you can talk about over then in 4-dimensional space-time.
It's a way of looking at things, if you like, which physically we seem to be forced into. That is, when I say physically, I say from the point of view of what relativity tells us. And relativity is extremely well tested, something like 14 places of decimal. I mean, it's incredible. So that we know that this theory does describe the universe to an extraordinarily precise degree. So we have to take it seriously. And that theory tells us that we have to regard space and time as part of is one thing. It's all out there as one thing. In the same sense that space is out there, time is out there.
Like the medieval god's view of time, Einstein's physics says the future is already out there. The moments of our lives just waiting for us to step into them.
But there's no more problem about the future being out there, in a sense, as there is with the space being out there. I mean, you say, Mars is out there, you see, and why is that any more comprehensible than, say, next week is out there? I mean, it's just as far away in a certain sense. Well, in a certain sense, Mars is still out there, but it's not something we're immediately accessible. We can't immediately access Mars.
If you take this block 4-dimensional space-time literally, it means you have to abandon free will. It means not only is the future preordained, but it's already there. It's already happened. There's no point making any decisions. Whatever you do has already happened. If I choose to drop a stone into a pond, I think of it as being my free choice. But of course, in 4-dimensional space-time, I had no choice in dropping the stone. The splash that is already there in the future, and so we lose all free will. If time travel were possible, then you can imagine people coming back from the future to visit us, there's no good us saying, you can't exist, you haven't happened yet. They've come from a time that they consider as their now, and for them, we're in their past.
So this means that the future and the past are all, in a sense, out there. And that also gives us a very deterministic view of the world. We have no control, if you like, of what happens in the future because it's laid out. I think the trouble people have with this idea is that you think of the future as being under your control to some degree. And so this means that if the future is laid out, then in a sense it's not under your control.
Personally, I'm very uncomfortable about the block universe idea. Now, this may just be a gut feeling, maybe irrational, but I can't accept that the future is already out there. I can't accept that I don't have any free will.
I think there is a positive side to this picture of space and time being laid out there as 4 dimensions, because in a sense it tells you that all times are there at once, and it can affect how one thinks about people who have died. I mean, I remember thinking in this kind of way when my mother died. In some sense, she was still there because her existence is still out there in space-time. Even though, in the normal way of thinking, at our time, she's not alive. A colleague of mine, one of his sons died in tragic circumstances, and he was a relativist. He is a relativist. I mean, that's to say, someone who has worked in Einstein's general theory of relativity. And so I presented this view of things to him, and he found this reassuring. This was before I learned that Einstein had also taken the same line. When his colleague Besso died, Einstein wrote to Besso's wife, and in this rather reassuring way to say that Besso was still out there in a sense, because space-time is laid out, and so it's somehow reassuring. I certainly think this way often. I think of somehow space-time is laid out, and therefore things in the past and things in the future are, in a sense, out there still.